Now, from the year 2023, problem like this has started coming a lot. This is a very tricky problem. I wouldn't do problem like this in the first round. Because if we divert from the proper way, problem like this can take you down a rabbit hole. So you wouldn't have any idea about the time, and you will be spending a lot of time to find the answer. So that's the reason you should be very careful about this problem. Anyway, let's try to solve it. PQR be a three-digit number. PQR be a three-digit number. PPT is another three-digit number. PS is a two-digit number where PQR and ST and T are distinct non-zero digits. Distinct means they should not be same. If P is one value, Q should not be that same value. Non-zero digits. All of them are one-digit numbers and they should not be zero. Now they are giving us this thing, that is PQR minus PS is equal to PPT. From this thing, I can directly eliminate P and P, and I can write QR minus PS equal to PT. The reason why I can do this thing is that I'll give you a simple example. If I have a equation like 356 minus 21, I'm going to get the answers to be 5. Okay, 5 minus 2 is 3 for you. 335. This value has come at exactly like that. No one has tested it. 356 minus 21 is 335. I can simply eliminate this value and simply write like 56 minus 21. I would have got 35 itself. I can do this thing because I can separate this 3's. I can separate this 3 and write it as 300. I can separate this 3 and again write it as 300. See, 300 plus 56, 356. 300 plus 35 is 335. And this 300, this 300 got cancelled. I can write it like this. Okay. Similarly, I can simply eliminate the first piece. So equation will become like this. Now I can expand. See, QR, that is 10Q plus R minus PS will become 10P plus S equal to PT will be 10P plus T. This is the place value expansion. That means if I am expanding 234, it will become 200 plus 30 plus 4, or 2 into 100 plus 3 into 10 plus 4 into 1, or simply 4. Or if I am expanding PQR, like the number was PQR. Yeah, if I am expanding that, I am going to get 100P plus 10Q plus R in a similar manner. Okay, you can even do that in the first term. Still, it will eliminate 100 P's from both sides and become like this. Now, taking this minus inside, I am going to get 10Q plus R minus 10P minus S equal to 10P plus T. I'll simply take this both to the other side. 10Q plus R is equal to 10P plus T plus 10P plus this is P plus S. And if you look, 10P plus 10P is simply 20P. So I'm going to get 10Q plus R is equal to 20P plus T plus S. Now, the question is giving us Q is equal to 3 and T is less than 6. If Q is equal to 3, then I can substitute this value. 10 into 3 plus R is equal to 20P plus T plus S. That is simply 30. Taking 30 also to the other side, I will get R is equal to 20P plus T plus S minus 30. Okay. We have to find the combination for R and S. And T is less than 6. That's another information. T is less than 6. So since all are one-digit numbers, because only then we can make three-digit number like PQR. The number for possible value for T is 1, 2, 3, 4, 5. 6 cannot be there because it's less than 6. That's given in the T is less than 6. It cannot also become 3 because 3 is assigned for the value Q. We have heard that they are distinct. Now this is the case. Now we have to find the combination for S and R. S and R. So P can be anything, right? Let's see. I'm going to assume that let P is equal to 1. If P is equal to 1, this equation will become R is equal to 20, this minus 30 plus T plus S, or simply 20 minus 30 will become minus 10. Okay, minus 10 T plus S. That's one combination. If P is equal to 2, I am going to get 20 into 2 plus T plus S minus 30. 20 into 2 means 40 minus 30 will become 10. And P is equal to 3. Similarly, it can become 20 into 3. 60 minus 30 will become simply 30 plus T plus S. Now, if you observe this thing, see, R is a one-digit number because it is part of a two-digit number or three-digit number. So, it's a one-digit number. In this case, it is actually possible. Okay, because if I rearrange a thing, it is going to become T plus S minus 10. T and S are one-digit number. They are adding and 10 is getting subtracted from them. But if you look in the second case or the third case, T and S are positive one-digit number, and this is 10 and this is 30. This will anyway be a number greater than 1. Okay, actually it is going to be a number which is greater than 3 according to the question. Anyway, let's assume it's a positive one-digit number. It's going to be greater than 1. Here also it's going to be greater than 1. That basically makes a number R greater than 11 and 31. Can a one-digit number become 11 or 31? No. In fact, any other value for P will still make R a two-digit number. So P cannot be 2, 3 or anything. This basically proves us that P can only take the value of 1. Only then R is going to be a one-digit number. So from here we also have assigned the value to P. P is going to be 1. So T cannot take the value of 1 also. So P's value is also fixed. When P's value is fixed to be 1, we got this equation. That means R is equal to T plus S minus 10. Okay. Now we have to assign the value of T. Now T can only take 3 values, 1, 2 and 3. Because T should be a value which is less than 6. Out of them, 2 values are, one is given to P and one is given to Q. They have to be distinct. So value of T are 2, 4 and 5. Let's put all the values and see the values which R is going to get. So I'm going to say that if T is going to be 2, 4 and 5. Okay, I want to find the value of R, which is equal to T plus S minus 10. Do we know the value of S? We don't know, right? Okay, don't worry, we'll still find. If you put this value, if T is 2, R is going to be T is 2, that is 2 plus S minus 10 will make it S minus 8. If T is 4, 4 plus S minus 10, that will become S minus 6. Yes. If T is 5, that is 5 plus S minus 10, that is S minus 5. So we found the relationship of R and S. This many possibilities of R and S can happen. So out of the numbers, totally we have the one-digit numbers are, one-digit non-zero numbers are 1, 2, 3, 4, 5, 6, 7, 8, 9. Yeah, this many numbers are there. In the first set, 1 is already taken by P. In all the set, 1, P and Q are assigned. We cannot give the number 1 and 3 to anyone. And T can only take the values which are less than 6. So in the first case, I have given the value of T to be 2. Now the remaining 4, 5, 7, 8, 9 values are free. Now T, in this case, the 1 is occupied, 2 is occupied by T, 3 is occupied by Q. Remaining values are still available. 1, 2, 3, except other values are still available. So I know that R is equal to S minus 8. So let's find the combinations of R and S. So 2, 3 and 1, 2 and 3 are occupied. Anyway, here I can clearly see that S is a bigger number. So I can take it like this itself, or I can take 8 to the other side and call it R plus 8 is equal to S. Okay, r plus s equal to 8. Now, s is a bigger number. So let's start with the smallest possible value for r. The smallest possible value, 1 and 2 and 3 are already occupied. According to 1 is occupied by p, 3 is occupied by q. According to this question, t is occupied by, according to this option, t is occupied by t. So even if I give the smallest value, which is 4, which is available for r, 4 plus 8 will become 12. That eventually make s a 2-digit number. That's the smallest value. Any other value I give will be creating a value which is greater than 12. All are 2-digit numbers. S cannot be a 2-digit number. That basically means this scenario will not happen. Now we have to go to the next scenario. Again, here I can say r is equal to s minus 6. Taking 6 to the other side, I can say r plus 6 is going to be s. Here the values which are occupied, 1 and 3 are occupied. And t is 4. So 1, 3 and 4 are occupied by P, Q and T. The value which are available are 2, 5 and so on. Now let's see. If I am taking the value of R to be 2, 2 plus 6 is going to be 8. That is a combination. R comma S can be 2 comma 8. Okay. Now the next combination, if I am putting this instead of 2, if I am taking 5, 5 plus 6 itself is becoming 11. So this is a S cannot be a 2-digit number. So that's it. I don't even have to check the further values. Now let's take the last case. So from here we got one combination for R comma S. Now let's take the last case. Where T is gonna be 5. There we got R is equal to S minus 5. R is equal to S minus 5. Taking 5 to the other side, I will get R plus 5 is gonna be S. Here the values which are occupied are 1 is taken by P, 3 is taken by Q and T is going to be 5. T is going to be 5. The value which are available are 2, 4, 6 and so on. Okay. So if I put the lowest value 2 plus 5. Yeah, it's a 1-digit number. This is okay. So R can be 2 and S can be 7. Another possibility other than this. So the next possibility I'll take R to be 4. 4 plus 5 is going to be 9. Even that is a 1-digit number. That's also okay. R is 4 and S is 9. Now if I take any other value, for example 6. 6 plus 5 will create 11. That's a 2-digit number. That's not possible. So here we went through all the possible cases and we found that R comma S can only become 2 comma 8, 2 comma 7 or 4 comma 9. Only 3 possible solutions are there for this case. R comma S. So the answer for this problem is option B. And believe me, I hate this problem. My God. In fact, even if I can do this problem, I would skip this problem in the examination hall. I don't want to waste this much time on a problem. Yeah. Let me know if you guys have any easier method to do this problem. Thank you guys.